Number 50. $50 and where? 2.3?
No, 3.1.
3.1. All right. All right. So in general, this idea of percent change actually did come up back in 2.3, but percent change is the new minus original divided by the original. So for example, if you had a shirt, used to be $10 and now it's $12, right? It's marked up to $12. So what's the new price? $12. And what's the old price? $10. And what was the original? 10. So the percent change is related to 2 out of 10. I can make that into a percent real easy. Yeah, because I can just multiply top and bottom by, what does percent mean? Out of 100. So I can make the bottom 100. Bam! So that's 20%. So that would be a 20% increase in price.
But on this particular one, our answers are going to vary depending on how we make the graph, right?
Yeah, estimate. It says estimate. So it should be close, right? So obviously I'm going to give you some range depending on what you see. So it all depends on your eyeball. Whatever you pick the points out to be, that's what you use. Okay. Yeah, if it's way off, I'm going to say something. Yeah, but if it should be just close, you're fine. Okay, baby. Yes, ma'am.
Number 24, section 3.2.
24? No, just make sure I heard you. 24? Let's see. I know that we haven't officially gotten in here yet. Let's see. But this one should be one we could do because we've had one like that before. So 24, this is section 3.2, looks like this. So I'm just going to do one of these and then you'll see how to finish the rest. They do their XY tables laying down. I'm used to it being like this, so if you're used to being like that, you'll be like that too. So this one has, they give us the Y's, I think. And then you got to fill in the X's, right? So how the hell do you do that? What does this mean? What is this shit? Yeah, so we have an equation. We have a relationship between X and Y. So when X is something, you can figure out what Y is. When Y is something. So in this entry here, I know what?
Y.
Y is 9, negative 9. So what can I do with that? Plug it in. So then I got, for this entry here, it's 3x minus 5 times Y, but Y is negative 9. And then you solve for X. So you're finishing out that. So the answer, any answer to this equation has to have how many parts to it? How many parts does any answer to this equation have to have? How many variables are there in this equation? So how many parts must there be? 2 answers, 2 parts to the answer, right? So this is the Y piece. I'm trying to figure out what the X piece is to make it work. Cool. I like it. Jeff got it. Make it work. Is that enough? Is that enough to get you going? Because now you just do that for each one of these. Yeah. So whenever you see a table and they have part of it completed, the other part not, you just plug it into whatever they told you. You saw some problems like that before, written a little bit differently. Yeah. Notice this. Let's do the first couple real quick. I want to show you something. How do I solve this for X? Yeah, what is this? Yeah, so this is 3x plus 45 equals 30. Subtract 45. 3x equals Negative 15, and then divide by 3. So I've got negative 5 there. Now please understand, please listen now. If you want to pass this class, if you don't want to pass this class, why are you here? If you want to pass this class, you have got, right now, this should be easy. This should be easy. If it isn't, come see me. Everything we're going to do is going to somehow boil back to this for the most part. Most of the time, it's going to boil back to solving an equation. So if you have any trouble at all with this, you have to come see me. Don't feel bad, just come see me. We'll clear it up. All right, cool, maybe. A few of you guys, if you don't come see me, I don't understand you. You got to come see me. So what about the next guy? How do I get this? That's crazy. Plug in negative. So do the same thing I just did. Set with a negative 6. So let me go through this a little quickly. This will be positive 30. This one freaks people out a little bit. I got 3x equals 0. That's not undefined. Yeah, exactly. Now, let me ask you this. This is related to a question on the homework. Real quick. If I had 3x equals 6, what would you do? X. Divide by 3. If I had 3x equals 8, what would you do? Divide by 3. If I had 3x equals 0, divide by 3, right? It's not the number on the other side that's telling me what to do. It's why x is not by itself. That's what's telling me what to do next. Not the 0. Don't go, oh, 0. No. 3x, divide by 3, because you don't want the 3, and then you worry about what's going to happen next. The thing you got to remember is, if I got nothing and I got 3 people, how much does each person get? Nothing, right? Three people looking to pay me my bills. I got nothing. You're getting nothing. You get nothing. You get nothing. Right? Look under your desks. Nothing from me. Whatever you put in there. Sorry. That's evil Oprah a minute. Now, real quick, on the homework, now watch this. If I had 3x equals 6, you divide by 3, right? If I had 4x equals 6, you would divide by? 4. If I had 5x equals 6, you divide by? 5. Holy shit. If you had ax equals b, you would divide by? A. See, math doesn't give a shit what's in it. Math doesn't care what's in there. Math just cares, is it an equation? This is how you solve it. I don't care what it looks like. I don't care if there's letters. I don't care if there's pi. I don't care if there's 0. I don't care. Math doesn't give a shit. You always do the same thing, just with whatever it is. Because that's the established procedure that will work. All right. That was a big tangent. Coming back to this problem. So we got, what do we get? Finally, we get 0. How much did y change by? It's a weird question. It went up by 3. Is that, you guys see that? Yeah. And how much did x change by? It went up by 5, right? All right. Now take a second. This is all review, and I love that this is all review. Everybody, this is not part of this problem. This is Jeff doing his weird shit. Solve for y for me. This gave us some trouble. Solve that, get y by itself in that equation. There are several problems in the homework that look just like that. Some of us managed to have x escape. You can't. There's an x in that equation. There always has to be an x in that equation. So you can't suddenly subtract it and it just goes away. Bye. It's got to be there on one side or the other. Get y by itself. All right, good. It's a good first step. Why is the y term not by itself? Because this stupid dude. How do you kill that guy? Subtract 3x, because it's positive 3x. I like it. I'm doing this order for gather 50. And then what? Divide by negative 5. Can't add 5. This multiplication, addition can never cancel that. It's not powerful enough. You got to divide by what you don't want there. I put it under each piece. You guys with me so far? All right. So finally, I get y equals negative 3 over negative 5 is 3/5. 30 divided by negative 5 is negative 6. Cool. So watch this. The y is changed by 3, while the x is changed by 5. Yes, ma'am?
Isn't it negative 3/5?
No. Because the negatives do what? Cool, I like it. Let me do this again. All right. I just lost what I was, can't remember what I was about to do. We'll see. So when the x goes, and tell me which direction is x? I just did it, but which direction does x go? If I change x, visually what happens on the graph? What changes? If I move x, so if I am at x equals 0, but I go to x equal 1, which direction am I going to go? Yes, right. And when y changes, it's what? Up or down. Okay, so x is left and right. Y is up and down. Cool. So this says, when I go 5 over on the x, I'm going to go up 3 on the y. So that's slope coming up to us. That's eventually going to get here. You can actually see it happening, though. And once you see that, here, watch. Okay. Man, you guys are so... Well, at least you're looking this direction. But your looks on your faces are like... Can you make this more boring, Jeff? I'm trying. I've got to figure out a way. There's got to be a way to make it more boring. Watch. Now watch. Here's the thing. The beautiful thing about math is the more you realize what's going on, the less you actually have to do. So I'm going to do this one way, and then we're going to do it the other way. Watch. If I go up by another 3, how much should y go up by? By 5 again, right? That's the established way that this line works. If I suddenly went up by more on the x, then that would actually kind of make my line turn. But this is a straight freaking line. It's got to do the same thing every time. So it should be a 5 here. Let's check it. When I plug a -3 in. When I plug a -3 in for y, right, just like we did here. When I plug a -3 in for y, I get 3x plus 15 equals 30. Subtract 15, 3x equals 15. Divide by 3, you get x is what we already got with a lot less work. Holy shit, slope is useful? What? Anyway, all right. So there's a little preview of something to come. All right. So I went with that problem, just to make sure you guys understand. All I have to do is fill these in. Everything else I've done is just kind of like a review and expanding on it a bit. I tend to do that. Just want to make sure you guys understand when somebody's going to come and say, "I didn't say to do it." No, just fill these in by doing the work. That's all I got to do for right now. Okay. Anything else? Oh.
3.242.
Oh, so hold off on that. We're going to build our way up to that today. All we did last time was graph points, I'm pretty sure. Right? I mean, we didn't really get to the point where we're graphing equations yet. So let's do that. Let's get into that. Anything else from homework? Question? All right, let's do this. Let me do this in a weird way. I don't care. It's all weird anyway. Help me out here. No. Let's not go there. Watch. We're going to leave it in English for a minute. Every time. So tell me, a general point. What's in this place and what's in that place? That's something that came out last time. X, Y. Beautiful. In fact, it's always in alphabetical order unless stated otherwise. So if you have an equation with a C and a D in it, what's first? C. It's crazy. All right, good. Remember that. That might come up. So this is always X, Y. So if this is the rule, that tells me how my specific points that I want to look at relate to each other, or the parts of it relate to each other. If X is 1, what's Y got to be? 3. I love it. Cool. Right? This is just English. There's no real algebra up here. Whatever number I put there, that's got to be 1 more than twice that, right? So that would be 3. What if it's -1?
1.
So what's twice this? 1 more than twice this. What's twice this? What's twice -1? 2 times negative 1 is
Negative.
negative 2. Increase that by 1. Negative 1. All right. Okay. And let's do one more. If it's 3, what would that y piece be? 7. Kick ass, right? 1 more than twice whatever the hell I put there. Now, of course, we talked about this last time, I believe. How long would that list be? Infinitely long, right? Because I could pick 1.1124996.3, my favorite number. I can put whatever the hell I want to there and just follow the rule to get the other piece, right? This could go on forever. Good God. So like I did say this last time, that the visual, the graph, is the quickest way to answer the question, what are the answers? Because then they can go find whatever answer they want. So these points specifically, the last time we did some points and they were just all over the place. We just made the points up. They were in the book. We just made the points up. They didn't come from somewhere. So there didn't have to be a pattern. If the points come from somewhere, there very well might be a pattern. This comes from a linear relationship. There's no squares or anything like that. Right? Nobody's cubed. Nobody's doing anything weird. Right? So this is going to be a nice straight line. If I graph these bad boys, take a minute and graph those points. Those 3 points. However you want to, as long as it's legal. Oh yeah, we did do a little bit. All right, let's see. Catch up to you guys. So my x's are 1, negative 1, and 3. So I can make that like that maybe. My y's have to go up to 7. So let me do 2, 4, 6, 8. First thing you do when you're about to graph something is you pick a scale for things to fit. I made a big deal of this last time, that your scale has to be consistent, or else it's going to get shut right back to you. I say, do it over. So 1, 3, where is that? So I can start here and I go 1 over, up 3. Cool. So wherever your scale is like, you put it wherever the 3 ended up. What quadrant is that in? I like it, the first quadrant. And they go quadrant 1, 2, 3, 4. They go counterclockwise. Just to be, I don't know why we did that. I wasn't around. So what the?
A quick question. If they, let's say for example 07 or 08, and then it asks you what quadrant is that?
Then you say no quadrant, it's on an axis. Yeah, the axes themselves are not in any quadrant, they're sitting on the fence. So you hear the expression, you're on the fence about something? It's an older expression about what the hell. That means you haven't decided which side to fall on. You don't know. You're not on either side. So if they ask you where is this point, what quadrant is this point in, you would say no quadrant. It's on the y-axis. Not really a trick question, but pretty close. And then -1, -1, what quadrant would that be in?
Down.
Third quadrant, 1, 2, 3. I love it because you go back 1, down 1, and then 3, 7. It's going to be back in the good old first quadrant. 3, 7 will be about right there. And there's my line. Yes, Jeff, that is like the straightest line I've ever drawn in my life. It just happened. And it's not straight, but it's all right. It's pretty close. So for you, if you want to, a ruler's awesome. Dear God, people, let me say this right now. You listen to me. This, if you give me this on homework, hell no. Hell no. No. Scale, work, points, show me some detail, right? It's going to get thrown right back at you. It's no good. No good. I want to get you there right now. The further you go in math, the more important it is to really show the details of a graph. Okay. A couple things I want to point out. Well, first off, let me go with your earlier suggestion. How do I write this in math? It's in English right now. How do I write it in math?
Minus 2x plus y.
Yeah, so y is
2x
y is 2x
plus 1.
plus 1. Cool. So that's the equation we're using, right? And those points came from that equation because they came from some defined thing. They're going to have a shape. So if you come from something, I don't know if you guys know, if you come from something with an x squared in it, does anybody know what that would look like if you drew it? It wouldn't be a straight line. It'd be beautiful. It would be something like that. The minute you don't have first powers, the minute you have something other than a first power, you see how both of my variables have a first power? We don't normally write them up there, but we know they're there. The minute it's not a 1, it's a 2, it's a 1/2, then you get curvy lines. Interesting. So we call this, remarkably enough, we call this a linear equation because all of my variables have first powers. Not linear, not a first power. Cool, I like it. I like it, maybe. And why does it make sense? Because it makes a freaking line if it's linear. That's why we call it linear. We're very creative. Very creative, our math people. Okay. So what's going to happen in section 3.2? And this is where they just barely introduce you to this idea of getting points from a certain place and they're going to make a certain picture. And we're going to deal mostly with lines right now. Later we're going to deal with parabolas, better known as parabolas. You guys are like, does he know how to say it? All right, let me do this. This is a little more interesting. So do number 2. Oh, this is on page 32 if you have your blue book. If you do not have your blue book, recreate that and do it. So here you got to be a little careful because they give you different values for different variables. Careful where you put them. All right, let me catch up to you guys on that first row. What do you do?
Hey.
Yeah, plug a 0 in for x, you get 4 times 0 plus 3y equals 24. One of my favorite things is sometimes somebody has 4 still there. 4 times 0 is, yeah, it's gone, dead.
So you get 8.
Yeah. Y is 8 when
X is 0.
x is 0. It's important to realize. Don't have a value for a variable and just kind of throw it somewhere. It's got to go with a specific value for the other variable. That's why if x goes up, y is going to maybe go down. We'll see. So right now when x is 0, I get y is 8. So how do I do the second row? Yeah, plug a 0 in for y.
Yeah.
So you get 4x plus 0 right? 3 times 0 will be 0. 4x is 24, so then x is 6. That's crazy. And then the third one, how do we do that, dude? What does Siri say? Stop talking to her. Who's doing that? Stop. So what do we got? 4 times 3 plus 3y equals 24. 4 times 3 is 12. Plus 3y is 24. Subtract 12. 3y is 12. Divide by 3. Y is 4. So put 4 right there. Now I've got my collection of points. 0, 8, 6, 0, and 3, 4. I got my 3 points I can graph. You need at least 2 points, obviously, for a line. 1 point ain't good enough. I love it when somebody gets 1 point and they just go, yeah. No, you need 2 points to tell you what direction the line's going. The third point is just to make sure everything looks right. If it's bam, 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 something's wrong. So now how do I graph? Let's see, 0, 8. Yeah, so Esther, you had a good point earlier. That point, what quadrant is that point in? No quadrant. It's on the, which axis specifically? Y-axis. Stop talking to me. Beep, beep. Store all your electronic devices. So anybody know what we call this thing? Since it's on the y-axis, that's where the line hits the y-axis. That's called the y-intercept. Kick ass. So wherever something hits the y-axis is called the y-intercept. So amazingly enough, when it hits the x-axis, we call it the... That's crazy. So 6, 0 is going to be where? Yeah, I go 6 over, and I don't go up or down at all, so it's right there. So that, of course, is like I just said, the x-intercept. Sure. And then finally, whatever other point I plot has got to fall on the line that thing would make, right? So if I had brought, yeah, I sort of do. So before I plot that last point, let me try to connect these with my approximation of a ruler. That's awesome, Jeff. That's awesome. All right, thanks for being there to laugh at me. So if I plot this point now, 3, 4, oops, sorry. 3, 4, where's 3, 4? 3, 4, bam! Sorry, I got excited. So so tell me something about that point. You can't tell me what that point is. You can approximate it. But what's true about that point that I just made, this point?
It's a negative slope.
No. The line has a negative slope. That point that I just pointed out, what's true about it? It's on the line, beautiful. Now, more importantly, what does that mean?
It's an answer to the equation.
It would work in the equation. Whatever, if I could figure out exactly what that point was, if I plug in those x, y values, it would work in the equation. Kick ass, right? It goes back and forth. Anything on the line is an answer to the equation. Any answer to the equation I put as a point on the line. Big. Here, so do number 4 real quick, and then we'll kind of move on. Notice what number 4 says. Let me try to catch up to you guys. To solve this for y, what would you do first? So you get 2y equals. And I'm going to shove this negative 3x in front of the positive 6. Just get used to doing that. So you guys know why. It's just that's the form of it. Just makes it easier to identify certain things. So are we cool with that? So this is 6 minus 3x, which is the same thing as negative 3x plus 6. I can turn that around. And then the last thing here is divide by 2. So you get y equals negative 3 over 2x, comma 2, plus 3, hey guys. Now notice what's happening to the poor x dude. Yeah, there's a fraction in front of it. Damn, and what's on the bottom of that fraction? A 2. So if I'm smart, because I'm allowed to make a table of values, I could put 18 billion in there if I wanted to, but probably won't because my graph only goes up to 5, right? I'm going to put numbers in there that act nicely when divided by 2. So what kind of numbers am I going to pick to put in for x? What kind of numbers would be divisible by 2? Even numbers. So if you picked a 3, you got some ugly fraction that you should still be able to graph, but you did it to yourself. It's not the problem's fault that it was that hard. It was your fault. So you pay attention to what's happening to the x. And you pick smart values of x. If I pick even values of x, it's going to come out to be a whole number. Because they're divisible by 2. Let's try. Obviously, a really good value for x, almost always, what's the best value for x? 0, because it kills that thing, right? So if I plug a 0 in for x, y is, holy shit. Yes, ma'am?
Why wouldn't you just plug a 0 by the 3x like you did for number 2?
Just because the instruction said to solve for y first. That's all. Is that? Are you worried about like plugging a 0 in for like 3x?
Yeah, you go 3x or 3 times 0.
You could. You totally could.
Okay.
But this problem wants us to use the other form of the line. Because we're actually going to use this other form of the line more often. But for tables, I agree. You could totally do like we did in the last one.
Okay.
But I like this one because it's going to point out something I pointed out up here. Let's go ahead and plot that point real quick. I want to point something out about that point. 0, 3, where the hell is that? Good, on the y-axis there, we go 0 left and right, up 3. So that is the what? Y-intercept. What would I change about this equation if you totally could? If you were math god and you could reach down and change something about this equation, how would you make the y-intercept be 4? Sometimes your reactions are awesome. Yeah, so I would change that 3 to a 4, right? I really want you guys with me. Some of you guys know where I'm going with this. Some of you guys are totally lost. So it's really interesting teaching this class. The reason that my y-intercept was 3 is because when I made x 0, in fact, whenever I make x 0, it's going to be on the y-axis. Think about it. If x is 0, how far do I go left and right? None. I only go up and down. Therefore, that's going to be the y-intercept. So how do I find the y-intercept for anything? I make x 0. In fact, more generally, how do I find the any intercept? I make every other letter 0. So if you had 26 letters in your equation, and you want the w-intercept, you make all the other letters 0. Let's bring it back to something we got to worry about. But this is crazy. This is true forever. So how the hell do you think I would find if I wanted the x-intercept? I'd make y 0 if I wanted to, right? We could do that. Let's try it. And then we'll get one more point that's nice. So what happens, now here, what sucks about making y 0 is I solve this easier up here, right? So if I make y 0,
X is 2.
yeah, so it comes out nice actually. So if I make y 0, this would be gross, but let's go back up to here. If I made y 0, x would be, divide by 3, x would be 2. I like it. So let me reiterate. To find the y-intercept, I make x 0. To find the x-intercept, I make y 0. Because if the y is 0, I didn't go up or down at all. So I'm on the x-axis. Let that make sense. Don't let that be something you memorize. Just go, holy shit, that makes sense. Bam. Let's find one more point. So here's 2, 0. What's a smart thing to plug in for x? Sure. -2. Even kind of numbers, right? Something divisible by 2. So when I plug a -2 in for x, let me do it real quick. -3/2 times 2 plus 3. Those go away. What am I doing? -2. There you go. So -3 times -1 is 3. Plus 3 is 6. I like it. And does that follow the pattern? Yes, because as I go back, I seem to be going higher. So -2, I'm at 6 now. Off this thing, but that's too bad for us. Ooh. Sure enough, that still maintains a line. Kick ass. Let me try this again. See how much purple I can get on this. What the hell's going on right there? Sound like a sitcom, kind of. All right, beautiful. So if somebody said, no, I wanted answers down here, you just go say, well, go follow my line. I'm done with it. All right? I've given you every single answer that exists. There's an infinite number of answers. Find whichever one you want.
Can you just grab it like you started at the 30 and go down to
Totally, but we haven't officially talked about slope yet. So if it says in the instructions, do a table of values, you must. If it doesn't say the instructions, then I'm totally cool with you doing it a more advanced way. That's fine. All right. Section 3.3, let me see if you guys can do this. We've already talked about this. What, Jeff? Here we go. Yeah, perfect. All right, this is page 34. Should I give you one with fractions? Yeah. Look at that equation. Isn't that yummy? It's number 4 on page 34. Here's the instructions. Find the intercepts and then graph the line. Find the intercepts and then graph it. So find the x-intercept, find the y-intercept.
Are we just doing number 4?
Just number 4, yeah.
Okay.
If you're not sure how to find the x and y intercept, you weren't outside the room. Everybody was here. We just talked about it, right? How to find the y-intercept, how to find the x-intercept. It always works the same way. It's crazy. Careful. Hopefully, coming from the right place. We'll see. You really don't have to do anything to the equation itself unless you really want to. You could kill the fractions, but there's so desperately not any reason for it. Because the minute I make x 0, for example, what would I find if I made x 0?
Y.
I'm going to find the y-intercept. So to find the y-intercept, let x be 0. So I get 0 over 2 plus y over 3 equals 1, but 0 over 2 is 0. So your y over 3 is 1, y is 3. Multiply by 3. Alright. Now, sort of made a mistake, not really. I'm going to leave that like it is. What about the x-intercept?
Yeah.
Let
Just y be
y be 0. It's crazy.
So Yeah.
X over 2 plus 0 over 3 equals 1. X over 2 equals 1. Good. X equals 2.
Yeah.
Multiply by 2. I like it. Let me stop there for a second. And now you guys kind of see what I mean about equations will never go away.
So the third step, for me, actually, I try to keep X like 4 because I recognize how to compare the numbers. So we will go on like this on the step 3, not step 2. I mean, it's done now for the one.
Oh, I see. If you wanted to find a third point.
Yeah, yeah.
Sure, you make X, it would be
4.
smart to make X something that's divisible by 2.
Yeah.
Sure, because the first thing that X has happen is it divides by 2. I like it. Or if you want to plug in something for Y, you would plug in something that's divisible by 3. Kick ass.
Yeah, yeah.
Now here's a mistake I made, and here's what happens. Somebody will plot the point 2, 3. 2, 3. They'll plot a point, and then they'll go, oh, draw a line. Do you see where somebody got the point 2, 3? In fact, that might be you. There is no point 2, 3 on this graph. There are 2 points we figured out. What are the 2 points?
0, 3, and 2, 0.
Yeah, y is 3 when x is 0. X is 2 when y is 0. Good, so we got 2 points. 0, 3, and 2, 0. So there, let me see if I can freehand this thing. Alright, there's the dangers of freehanding that. Get yourself a ruler or something. Or a piece of paper, if you don't mind marking it all up. Alright. Not too bad, right? That's a whole other way to do this. Find the intercepts. That's all you need is the intercepts, and you can plot this thing. I like it. Real quick. What are the intercepts on number 1? What's the y-intercept?
0, 3.
Kick ass. Say it like that. So the y-intercept is 0, 3. The x-intercept is?
-5, 0.
Cool.
Yeah, -5.
I like it. -5, 0. All right. Don't say anything for a second, Andrew. So what's the x-intercept on this one? What do you guys got? What's the x-intercept?
-1.
-1?
0.
0. Kick ass. And the y-intercept? Kick ass. 0, -6. I love it. Kick ass. So I might not take points off if you do everything correctly, but I will put I'll always try to get you to write things as a point. They have to be written as points because that's what they really are. If you don't write them as points, you could make mistakes.
Question. If you plug in the numbers and you get a straight line, but the numbers you plug in, they don't match with the answers at the back of the book, you give
there's only one line, right? For any line, there's an infinite number of points on it. So, are any of you guys artists? Any artists out there? Yes? A few of you guys? Have you ever heard like a sculptor says that the rock, he sees the marble and he says, I saw what was in it. All right, so what the hell am I talking about? So there's a line that exists for an equation and we're trying to see it. So we see it by getting points and then we plot the points and go, oh, there's the line. So I don't care if somebody gets two entirely different points. It's going to be the same damn line, isn't it? There is a line that we're trying to see. The points we use to see it could be different, but it's always going to be the same line. There's an infinite number of points that people could pick. So yeah, it'll be the same answer. It'll be the same line. I don't care if you use the same points the book does. I don't care. It's the same line. That's the answer, is the line. Cool. I like it. Okay. So here's the next weird thing. Let me ask you this, just in general. And I'm going to try to make a point of this. Obviously, in Chapter 3, you should expect everything to be two-dimensional. Are you with me? What do I mean by two-dimensional?
Not third dimension.
All right, good. It's more than just one axis. It's the two, right? And there's no third axis. You don't need glasses, special glasses, to see your answer. So, in Chapter 3, that's going to happen. Basically, everything's going to be on 2D. So what if I said graph this? It's more than a point. There are how many points follow what this says? One example is 3, 0. Cool. Why does that follow this? Why does that follow what that says? Because the x piece is 3. Can anybody come up with any other point that follows that rule? 3, 1. Holy shit. 3, 1. Why does that follow that rule? Because x is 3. I think you guys start to understand what I'm saying. So 3, comma, fill in your favorite number. 7. 3, comma, square root of pi. Sorry. 3, comma, whatever the hell you want it to be. So this is sort of the long way to do this, but I want to make sure you guys understand why this works the way it does. Plot these points. So 3, 0 is right there, right? 3, 1. You go over 3, up 1. 3, 7, over 3, up 7. 3, negative 100 billion. You go over 3, down 100. So the line is going to look like this, isn't it? It's going to be straight up and down, become big. So if you miss a point, just make the point bigger. It's a straight up and down line. Why does that make sense? I want you to really see how this makes sense. In a normal equation, let me see if I can do this kind of quickly. Y equals x plus 1. Stay with me. Stay with me. This is kind of cool. You got to stay with me. If x is 0, what's y? 1. Now let me move over. When I move the x by 1, now what's y? 2. 2.
Yeah.
So when y changes, when x changes, normally y changes. So if y changes, it goes up and down. When x changes, it goes left and right. Can x change? Yes, I think. Yes, exactly. We're not quite there yet, but I'm with you. 100%. Can x change? Does this equation allow x to change? No, this equation says x has to be 3. In which direction do I go when I make x change?
Y.
Left and right. So I can't move left and right because I'm stuck at 3. So which way can I go? What does this say about y? Does it say anything about y? No. So what can y do? Everything. It can do whatever the hell it wants to. So I can go up and down like crazy. I just can't move left and right. So that's why x equals a number is going to be vertical line. So remarkably enough, what do you think happens when I have y equals a number? Like y equals negative 1. What's that going to look like? That's insane. So at negative 1, I'm going to have, that's going to be the line. Because what cannot change now? Y can't change, so I can't go up or down. Y is up and down, x is left and right. Does it say anything about what x can do? No, it doesn't say anything x can do. It doesn't say anything x can't do, so x can do everything, and it does. It does everything. That is a flat line. Right? It's a horizontal line. Those are special cases. That's all in section 3.3, by the way. Horizontal lines and vertical lines. Time we got. Okay. Here's the last thing we'll do today. Tomorrow, I'm going to have a nice group work thing with everything we talked about today on it, so that I can shut up for not tomorrow, but you know what I mean. Tomorrow in context of the class. Thursday. Yes, tomorrow. That's right. Oh God. I teach a 2-day-a-week class, a 3-day-a-week class, and a 4-day-a-week class, and I'm always saying the wrong thing to them. I think you guys are with me. So tomorrow we'll have some group work with all this stuff on it. But the last thing I want to talk about right now is slope. I keep talking a little bit about slope. I just want to talk a little bit more about slope. So we're barely going to get into section 3.4. And tomorrow we'll kind of reel it back and go review all this stuff again. So let's say I have a ramp, right? A handicap ramp or just a ramp somebody put down to go up somewhere, versus stairs, like one stair that goes front, wow. So it goes over 2 feet, let's make it 1 foot, and up 1 foot. Which one of these would you say is steeper?
What, sorry?
Steeper.
Steeper.
So it's a very strange word. Does anybody understand what the word steeper? Which one's more steep? Steeper. The stairs would be, right? Maybe not by what I've drawn, but how steep is the ramp? So what math does is it comes in and gives us a way to measure, and we can measure slope without, well, no, we can't, not without math entirely, but without algebra we certainly could. But the way we talk about slope is, how would I make, let me do this, instead of the stairs, let me make a steeper ramp. How would I make a ramp steeper than that? What must it do to be steeper? All right, it's got to like go up, it's either got to go taller in the same like 8 feet, or it's got to go 2 feet in less distance, right? Either one. You guys with me?
Yeah.
So if I make it like run only 4 feet, but then go up 2 feet,
So, yeah.
that's going to be steeper.
Yeah, high.
Okay, good. I'd love to. Some of you guys know entirely what I'm going for. Some of you guys are like, what the hell happened? What's going on?
So always we
Ramps?
Yeah.
Are you going to make us deliver shit, Jeff? What's going on? Do you need help moving? No, I don't need to move. So the way we do this, the slope, mathematically, this kind of makes sense. Notice how how much I ran by, I'm going to call left and right running, and I'm going to call up and down rise and fall. It kind of makes sense. Run, right, run, left, rise, fall. Okay, good. All right, David Blaine. David Blaine, is it too old of a reference now? You ever seen the parodies on YouTube? That's funny stuff. David Blaine, no David. Sorry. So slope, we call it rise over run. Think about it. If the run gets smaller, if I divide by a smaller number, my answer gets bigger. So sure enough, if I do the same rise in less time, that's going to make a steeper ramp, is it not? So that makes sense, physical sense. No freaking way, Jeff. Math idea making complete physical sense. So this slope, what would this slope be? How much did it rise? 2 feet. Over the course of running?
8.
So this slope would be 1/4. This slope would be, yeah, it would rise 2 over the course of 4. It's 1/2. So this slope is twice as big as that slope. It is a steeper ramp. Chicken's the acid. I like it. Or you can go hiking. Talk about the difficulty of the hike based on how big of a change in elevation over the course of how much you walk.